Hello guys, we are Team 23 and we will be presenting our project Car Parking Assistant. And this is how our project looks. And now let me switch on the power and now you can see. In just a minute I can show you the basic working. And before seeing the complete working, now we will first see what's inside and the internal connections. Let me show you the internal connections and working of our car parking assistant. Alright, so the first thing first, the inputs, what we are taking as inputs from where. One of the IR sensors, we are taking the input at both sides, and one ultrasonic sensor we are using as input. So let's take a look at inside for outputs. We are using these two LEDs as output for the IR sensors, and for the rear sensor, ultrasonic sensor, we are taking using this buzzer and LCD screen for the output. So now I've told you the inputs and outputs. Let me tell you the working. So for the rear sensors, the thing is, this ultrasonic sensor would send us some parameters, technically speaking, trigger and echo values, which it is calculating, and then we will use some function on it, and then we can know the distance, uh, and that integer distance, basically float distance, we will store and output on this LCD screen. And we just don't need the driver to look at the distance and just the position of the car, but we need to alarm him if something bad is going to happen. So we will use the buzzer if the distance falls below some particular point. So this is for the rear sensor. For the side sensor, this IR sensor, the mechanism is pretty easy and less complex. The thing is, these IR sensor will just tell you if something is there or not. So if something is in front of this IR sensor for like 4 or 5 centimeters, then they will send the signal that something is there, and alarm you using these LEDs. These are red LEDs which will alarm the person and will glow on the dashboard respective side. Like if something is there on left side, the left LED will glow, and similarly for the right side.
Okay, so now I'll be explaining the code for a project. So let's start with the header files involved in this. So we have only one header file here, and that is used to include the liquid crystal library. And this is so that we can use the LCD screen efficiently. So this is the only header file here, and then we have declared a few global variables, and one of which is this object of the liquid crystal type called LCD. And as you can see, we have passed several parameters to its constructor, and each of these parameters represent various ports to which the LCD pins have been connected. And we have a couple of constant integers here, so that represent the trigger and the echo pin respectively. And then we have decided to store the distance as measured by the ultrasonic sensor in this float variable called dis, and to store the time delay between the emission and receipt of ultrasound on this float variable called duration. And now let's come to the setup function. In the setup function, we basically define which all ports operate in which mode and which all components have been connected to it. So we have set up the LCD screen here by doing this, using these two functions. The LCD.begin specifies that the LCD is a 16 by 2 LCD, and set cursor so that the cursor comes to the initial position. And similarly, we have set up, we have set up the ultrasonic distance sensor also. We have made the 8th port and output pin, and the 9th port and input port, and similarly for the IR sensor also, and also for the buzzer. Now let's come to the loop. The loop is what makes the code run. So this function gets executed again and again infinitely until we stop the system. So first of all, we have used this lcd.noblink so that there is no blinking cursor on the LCD screen. And then there is this chunk of code. So what this chunk of code essentially does is it makes the ultrasonic sensor emit a pulse of ultrasound for 20 microseconds, and then we store the time delay between its emission and receipt in this variable called duration. So this function pulsin basically helps us calculate the time delay. And then we calculate the distance by doing this duration times this factor. So this factor takes care of the speed of ultrasound in air. And we store the distance in this variable called dis. And then there is this chunk of code, so that helps us print uh, on the LCD screen, that is the distance is equal to this much centimeters. And coming to the IR sensor, let's have a brief of how the IR sensor works. So whenever there's something in front of the IR sensor, the output pin will be at low voltage, and when there is nothing in front of it, the output pin of the IR sensor will be at high voltage. So whenever there is something in front of it, we want to alert the driver using an LED. So we put the port to which the LED is connected at high voltage, so the LED glows. And when there is nothing in front of it and the output pin of the IR sensor it has high voltage, we uh, put the corresponding LED at low voltage, that is at zero voltage, and the LED does not glow. And is the same mechanism for the second IR sensor as well. And now finally coming to the buzzer. For the buzzer, what we do is when the distance as measured earlier is less than 10 centimeters, uh, we make we put the port of the buzzer at high voltage and the buzzer starts beeping. And when it is greater than 10 centimeters, we put it at low voltage and the buzzer does not beep. So, and then in the end, we give a 100 millisecond delay so that the code runs smoothly. So that's the end of the code. Thank you.
So now we will look forward to seeing it in action. For the sideways parking assistance, we have added one IR sensor as shown, and the output is given through the 1 LED. So we have set the distance of about 5 to 7 centimeter at both sides, which can be adjusted using potentiometer. And we have set here 5 to 7 centimeter, which won't be really practical in a cars, but we can adjust it. So this was the sideways sensor. So now I will demonstrate the rear sensor, which is telling the exact and precise distance of the obstacle which is there at the rear end. So let me zoom in for the um, LCD display. So you can see the LCD display. Now it will be earlier it was showing some garbage values because there was no rigid object behind this, but now I have put a obstacle, so it will show some precise thing. So now you can see that it is showing 12, 11, 10 centimeter, and when it will be less than 10 centimeter, it will uh, send the alarm signal and turn on the 5 volt for the alarm. Let me give you an estimate of how precise this thing is. Now I will uh, make this thing buzz, and you can see the distance. All right. So that was our car parking assistant DIY project for Team 23. Thank you very much for watching.